Thank you all for your great examples of independent variables. And, as an aside, no, the cups were not glued, nor am I editing any evidence from this footage. Good questions, though. Questions keep science going, so never stop asking them. So, here it is, the impossible trick shot. Somewhat unsatisfying. I'm sure you're looking for something more akin to this. But let's take a closer look. I think the reason this doesn't work is actually really cool. The first thing you should notice is the ball begins to spin immediately upon hitting the first surface. I didn't spin the ball on purpose. It happens because of how I set the experiment up. It happens with any ball. We call this a dependent variable. Next comes a fun part. A spinning ball hitting a surface doesn't act like a particle of light. That laser that I practiced with? Think about what happens when you apply backspin to a ball. Instead of bouncing in the direction you toss it, it bounces back to you instead. If we take a closer look at the bouncy ball hitting the mirror, it should have topspin to propel it forward. Instead, because its next bounce will be off the top mirror, it really has backspin and comes back to you. This works best with bouncy balls because they're really good at keeping most of their energy. When I tried with a volleyball, you can tell it loses a lot of energy in the first bounce. This might explain why volleyball players can dig a ball at 70 miles an hour and keep it in play. This experiment had a lot of areas for improvement. I could have been much more careful to control more of the environment. If something in your experiment that you didn't account for might affect the results, it's known as a possibility for error.
That's not right.
For instance, you might have noticed the chip in the mirror during the final test. That chip wasn't there when I took my initial measurements. It's possible the chip in the mirror makes the glass less stable and affects the outcome. So the chip in the mirror would be a possibility for error, something I should have controlled. On the other side of possibilities for error are control variables, things I choose to keep the same on purpose. They are still called variables because they could have changed the outcome if I had not kept them the same. An example of a control variable would be the size of the cups. If I had changed the size of the cups, it could have changed the size of the target. Thus, cups are a control variable. So, I want to see if you can spot at least 2 possibilities for error and at least 2 control variables in this experiment. Submit your answers to your teacher in your online classroom. I'm curious to see who can find the most.